So the lesson that I will be going over today is lesson 8 for graphing rational functions. So let's start with how to find certain types of asymptotes and points of discontinuity. You know that a function has a vertical asymptote whenever b of x is equal to 0. And when I'm referencing this, a will be the top function, b will be the bottom function. So if b of x is equal to 0, you know it has a vertical asymptote. So for example, you know that the function x squared plus 3 over x plus 2 has a vertical asymptote. You get x is equal to negative 2. And there is your vertical asymptote for this particular function. That's it. You just set the bottom equation equal to 0. There are two scenarios where you're going to have a vertical asymptote. The first scenario is if the degree of b of x is greater than the degree of a of x. If this happens, then your asymptote is at y equals 0. So, for example, if your function was x over x squared, because this degree of b of x is greater than a of x, you know your vertical asymptote is going to be at 0. The second option is if the degree of a of x and the degree of b of x cancel out leading coefficients. So for example, if you have the function 2x squared over 3x squared, the x's will cancel themselves out. So in this case, your horizontal asymptote is at 2 over 3. There isn't one more. It's not really a path or anything, but it's just a note. If the degree of a of x is greater than the degree of b of x, then there is no horizontal asymptote. So if your function is like this, a of x over x, you are not going to have a horizontal asymptote. The third kind of asymptote is an oblique asymptote, and it basically is just a slanted asymptote. This happens if the degree of a of x is greater by exactly 1 degree than the degree of b of x. So for example, your function is x squared minus 4 over x minus 2. The degree of a of x, which is 2, is 1 greater than the degree of b of x, which is just 1. In order to figure out what your oblique asymptote would be, you need to simplify first. So this is a difference of 2 squares, so you're going to have x plus 2, x minus 2. And the bottom is going to stay the same. And then you're going to cancel out these two terms right here, and you're left with x plus 2. So once you do this, you know that your oblique asymptote is going to be at x plus 2, and you just graph it like a line. So points of discontinuity are basically holes in your line where nothing can exist in that hole. It'll make more sense when I explain it. In order to determine if you have a point of discontinuity or a hole, basically, you need to have factors that cancel out on the top and bottom. So if we take the function from the last example, x squared minus 4 over x minus 2, and you simplify, you always want to make sure you simplify. As you can see, we cancel out the term on the bottom with the term on the top. This means that we have a hole. Your x value for the hole is going to be, if you set this equation that you just canceled out, the x minus 2, equal to 0. When you do that, x is equal to 2. So you know that the x value for your hole is 2. So now that you have your x value for the hole, you're going to plug it into your new equation, which I forgot to write down here, which is just the x plus 2, because remember these canceled. So you're going to plug 2 back in, you're going to get 2 plus 2, so your y value for the hole is going to be 4. So when you draw your graph, you're going to have a hole at positive 2, positive 4. I just leave an empty spot like that. And your graph is x plus 2, so your y-intercept is going to be at 2. And you're going to go up 1 over 1. Up 1 over 1, there's a hole, so your line's not going to be there. Up 1 over 1. Can do the opposite. So you have a line, but you have a hole. So it's not going, you're still going to draw your line, but there's going to be this point of discontinuity right here, and you need to make sure that you label that on your graph by using an open circle. So that's all. All you needed to know in this lesson were vertical asymptotes, horizontal asymptotes, oblique asymptotes, and points of discontinuity. Once you have these, you're ready to actually graph rational functions. Okay, so the example that we're going to try is f of x is equal to x cubed plus 4x squared over x cubed minus 16x. The first thing you're going to do is simplify it. So I know right away I can take out an x squared from the top, and it leaves me with x on the inside of the parentheses and a 4. For the bottom, I can take out an x, and I can take out, and I put inside the parentheses x squared minus 16. So right away, we know this is a difference of 2 squares, so we can further break this down as x squared, x plus 4, right? The top stays exactly the same, but the bottom turns into x, and x plus 4, x minus 4. From here, we can start to cancel things out, which indicates right away that we're going to have a point of discontinuity. So we can cancel out the x plus 4s, and we can cancel out 1x from the bottom and 1x from the top. It's a good thing to mention that you want to write this stuff down. So you have a hole at both, if you set x plus 4 equal to 0, you're going to get negative 4. So you have a hole at negative 4. You also have a hole at 0 because you canceled out an x. So those are the 2 holes that you have in your graph. So your new equation, once you cancel everything out, x over, right, you still have a 1 up here, 1x over here, over x minus 4. So that is your new equation. From this, let's figure out the other things that we need to know. We need to know what our vertical asymptote is, and if you set the bottom equal to 0, the x minus 4, you're going to get x is equal to 4. So your vertical asymptote is going to be x is equal to 4. For your horizontal asymptote, we're going to see if there is a horizontal asymptote. They happen to have the same degree, and if they have the same degree, then that means you're just going to go straight to the leading coefficient. In this case, the leading coefficient is 1 for both of these, and 1 divided by 1 is 1. So your horizontal asymptote will be at 1. There are no oblique asymptotes, because in order to have an oblique asymptote, the degree of the a of x needs to be greater than the degree of b of x, which in this case doesn't happen. That is all the information you need to graph. Okay, so first thing, our vertical asymptote is at 4. So you can go ahead and make a dotted line at 4. Your horizontal asymptote is at 1, so you can go ahead and make a dotted line at 1. So first thing is to plot the hole. We have incomplete holes, if you will, because we only have the x value. You need to find the y value. So you need to plug in your x values for the hole into the new equation. So your first hole is going to be at negative 4, positive 1/2. So we can go ahead and plot that right now. Here's negative 4. Here's 1 right here, so it's about halfway. We're going to plot a hole right there. Next thing we need to know is the other hole, which is at 0. If you plug in 0 into the new equation, you get 0 over 0 minus 4, or just 0. So 0, 0 is our other hole. So you can go ahead and plot that as well. Now that we have the 2 holes, we need to see where our function will lie. In order to figure this out, you need to find the y-intercept. So here is our here's our new function that we figured out. If we want to test a point to see if it'll work, we just test a point. So let's say I'm going to test 1 right here for x. So if I plug in 1 for x, I get 1 over 1 minus 4, and I get 1 over negative 3, negative 1/3. So here's 1, negative 1/3 would be right around here, which means that there's a point somewhere here in the negative 1/3 area, and so somewhere around here, which means we know that our function is going to look somewhat like that. And because we know that this function, it's either going to lie here, here together, or here and here together, we know that the other side of the function is going to lie right here. So that is what your graph would look like. You have a vertical asymptote at 4, horizontal asymptote at 1. You have two holes at -4, +1/2, and 0, 0. And you can plot any other point when you plug something in. I plugged in 1 and got -1/3. And then from there, you can go ahead and graph.